Today for me. This is part two or take two of my talk again. Before I get started, a big thank you to Kiran and Kamlesh and the entire React Day Bangalore team for organizing this entire event that is there. Doing something from a remote as a remote conference is extremely difficult because communication is async, and they've probably been extremely forthcoming and warm in the entire process, and it's been a very comfortable feeling. So we tried this in the morning, didn't go out as expected, had some internet issues probably on my side. I realized the chat is extremely hilarious, and there was like a riot on the chat, and there were a lot of funny quips and messages on that. So there's a good prospect for if people want to consider roasting people as a as an alternate option. But yeah, having said that, let's get started with my talk, which is on a thinking of UI as a finite state machine. So a little bit about me. My name is Nitish. I work at Myntra, and this is my Twitter handle. You can follow me here. And I talk typically around things around JS, around interfaces, a little bit of React, around cricket, recently on Golang, and also a little bit of chess. So right, we come to the point of what is an FSM or a finite state machine. Now, for someone like me who was from a non-computer science background, this was an extremely hard thing to grapple because this was something where I had no idea of what it was. And if you're someone who's probably worked from a or in a backend in a backend ecosystem, you will know what this is because backend architectures do tend to use this. So as always, like everyone does, the first thing that you do, you probably look at Wikipedia or something like that, and Wiki has like a definition which is along these lines, right? So it calls it a mathematical model of computation. Three words, as I said, if put together make no sense, and then below that there is some formula that they've added where uh, they say that finite state machine is a quintuple with some Greek alphabets inside it. Prior to this thing of knowing what a state machine was, I didn't know what the word quintuple meant. So that is like a new learning as well for me in this case. So I decided to probably go in with a approach where I can come up with my own definition of it, which is probably easy for people to understand and read. So this was my definition of it, where I can call it like an object in memory which stores the state of an entity and handles its transition from one state to another based on certain events. So you can think of it like an entity which you can be in your daily day or any daily day use, and you have possible states to describe what the entity is. And a state machine will handle transitions from one state to another based on events. So just throughout this talk, if I mention the word state, I'm saying the FSM state. If it is explicitly like a React-based state, I will call it as a React state. So let's take the daily example of a bulb, right? You have a bulb. There are two possible scenarios or two possible states that can describe this bulb. One is an off state, the other is an on state. There is nothing other than this which can describe what a bulb is. A bulb exploding is like a altogether different case, but in a normal utopian world, you will have two possible states for a bulb. You have an event that you pass or that occurs on the bulb, which is say turning on, which can be when you turn on the switch or you press a button on a remote, and it changes from an off to an on. Similarly, you have another this where you press it and it goes from on to off, and this is something which can be encapsulated, or this entire bit is something that we can call as a finite state machine. So there are finite states of the entity of a bulb, and other than these two states, there is nothing else that the bulb can represent. So it is a very deterministic behavior of an entity, which is the bulb here, where it can be either off or on, and you can turn it on or off based on the two events that come. So if you look around you, there are a number of events that sorry, there are a number of entities which can follow an FSM sort of a pattern. You have your microwave, you have a lift, probably some of the things that you use in daily lives can be used as FSMs, right? Or they follow the FSM architecture. Um, Now, most of us, I'm assuming here, do work in P2C sort of products or product-based companies where the end goal of whatever you're building is to do a transaction. It can be if you're in an e-commerce company, it is the user places an order and then it gets delivered to him. If you're in a company that is delivering food online, it can be something which places where you place the food and it gets delivered, right? So we take the case of a food delivery, the journey of your entity, which is your order here. So from order state, it goes to say an order preparing. Then you get to this that yes, food is prepared. Then you get like yes, I have dispatched it. Followed by you get the idea that yes, it has been delivered. Now in this entire thing, you know that at any given point, whatever state your entity is in, you know the next state, and based on a certain condition, it will only go in one direction. That is in this case, from food is prepared, it cannot go back to order is placed, or say dispatched. From dispatched, it cannot go to preparing. In a normal scenario, like a very simple, uh, linear situation that I'm considering. So if we had to think of what the definition of a state machine is, you can think of like something which has two state or an object which has an entity which has multiple states, and then based on an event, uh, the entity decides, do I need to go from one state to another, and this is called as a transition typically within the state machine. So there are a couple of mutations that occur inside this the transition bit, which is an on exit and an on enter. So these can be callbacks where while I exit from state one, execute some certain handlers, and while I enter into state two, execute certain handlers. So this is one thing where you can see that state is not the same as a state machine. So here now when I say state, I am talking about the React state. So React state is what defines your application, the data, the way you the view, the way you show your or the view layer or the data that powers the view layer is your React state. State machine can be something which supplies that bit of the state to your React state, right? Or it's like for a person who doesn't know what an state machine is, it's like a black box which tells you based on certain events what the current behavior of a certain entity is, right? Then next we come to the bit of why do we need to use state machines at all? Do we really need a state machine? Are we overcomplicating things? So state machines is something that is without us realizing, is a common language between developers and designers, and this has been there for a long time. So when your designer, makes mocks on say a Miro or an InVision app, it knows that yes, that if I click this particular button, you show this bit in the UI, or if I highlight this bit in the button, you show something else in the UI. So this is nothing but this is the behavior of it is fairly similar to a state machine that is there. And as I said, it's a common language because a designer gives you one particular mock, and then as developers, you're left to figure out probably all the possible cases, and then you end up writing conditions in your code. But if you have different states for an entity, for an input field or whatever, like in this example, like suppose you have a certain set of input fields where in an idle state, there's nothing written there. When I start typing, the button becomes green. When I make an API call, there's a label above, and say on failure, it becomes red, something like that, right? This behavior is very similar to what a state machine can be. Like you can define states for these input elements at the side. So what was the use case of our state, or why did we think of a state machine, this in the UI, implementation of the UI, right? So what we were trying out in our some of our warehouses was interacting with hardware readers, and these hardware readers typically send socket events to the browser. And this implementation of the stock is typically around the browser implementation of the UI that we had done. So we had a bunch of socket events from the hardware reader, which would give us certain data points. Then we had things where there were internet events like disconnections, then hardware events like disconnections. And of course, for any application to work, you also need API calls. So API calls is something that you need, as I said. And with the API calls comes the case of, if the API call fails, do I have an error mechanism? Do I need to have a retry? Do I need to have an autocorrection? Now, all of this was made in some of the warehouse applications, which are primarily designed for operational efficiency, where the output or the net goal of it is something which increases operation efficiency and is not very cumbersome for the user to consume. So the case here is that while an API call is made, if I get certain socket events or if I get some disconnection events, how do I handle it? What happens? And as a developer, yes, for you, you will understand that, yes, okay, disconnect the reader and connect it again or whatever, or disconnect some ports and run diagnostics again. But for someone who's working at a warehouse, these are not very helpful messages, right? So which is why the whole idea of an autocorrection and retry mechanism and things like that came, which the state machine did help us analyze and implement. So let's say we have an entity which is in a state of S1, and you have one event called E1, event 1, and it sends some data. So typically these events, when I say, can be of various types. It can be a click event, it can be a post message, it can be a socket event, it can be a browser-based event, it can be a custom event that you dispatch. It depends on how you define it. And this event has some data associated with it, and I have one state S1. So I'll typically have one handler to handle this event, right? In general, like you have a click that you do, you have one click handler for a button. If I have the same entity in 3 other states or 2 other states, so S1, S2, S3, and the same event has to be handled differently in all of them, then you will see like, okay, fair enough. I have 3 different states, so I can have 3 different handlers. This thing becomes like a m cross n problem, and automatically, if you have another event and more states, you can have 10 possible handlers. So one way is you have a nested switch statement where you have a switch first on the state S1, S2, and then inside that a switch on the event, which is actually a very verbose way of writing a finite state machine. And ultimately, that is what it actually does. So this approach was something where we thought that, yes, we can probably try using a normal FSM implementation where this handling of events is done out of the box, and my UI does not know what event handler is being called, but the state machine knows, because that's what the role of it is. So designing something or architecting something, we thought we'll keep it configurable. That means given a certain set of conditions or configurations, I should be able to reuse it. When I say reusable, it was not isolated. It was isolated from frameworks and wasn't, say, exclusively built just for React or for Vue or Angular. So that if I have to reuse it in another place, I'll be able to do that. Easy to subscribe to, when I say it's easy for anyone to use the API. So the components using this could have a subscriber mechanism which could use this and listen to events and then act accordingly. So we decoupled the state, the React state of a component from the state machine state of it, purely because one was separation of concerns. But if you want, you can also club the two and have like a use state machine hook which does that, which I've explained in the slides later. So let's assume you have a UI like this. The thing on the right is your UI. You have an events channel which the state machine is listening to, and you have a subscriber bus to which the subscriber is connected to. And you have events coming in which can be a click event, a scroll event, or a socket event, whatever. It goes into your event handlers based on the current state. It decides what to do, and assume this event was something that, yes, you have to change the current state to S2. This message is propagated to through a subscriber bus, and the components that are listening to it can can make an update in its React state, and then the view gets changed. So if I have to say maintain a definition of what the state machine is, it's like you can think of it as a class. I like the object-oriented sort of uh, approach that is there with this thing. So I prefer to choose a class, and you have an initializer at the top, followed by the events, the type of events. So there are two type of events that the state machine propagates. One is a transition from A to B, and the other are custom events, which are typically for any mutations that you want to do. So ideally, it's recommended that you do not use much of the custom events, because you can get into certain bugs or random changes which were not expected. But it's something that has been made available in case you have to. Handle event is the main handler of the state machine, where you say that yes, this is the event state machine, you do your magic and tell me what to do, and if there's a state change, propagated to the component. Uh, Dispatch event, as I mentioned, is a simple dispatcher. And then transition to next state is the main state, where if explicitly you want to transition uh, the state machine from state 1 to state 2, you're able to do that. So just coming to the definition of what these methods are. These are fairly simple methods. I will explain what the current state context is in an event, and it just picks up that particular object with that event name and executes the function associated with it. Similarly, for dispatch event, this is a listener, a list of listeners that you subscribe to. They just get called and it gets pushed. The callback gets executed. Then we come to transition of next state. So this is the state where the method which actually transitions to the other state. So you have three parts here. One is a validation. So this validation is something where when you define your state machine or the config or the schema, as we call it, there's a validation that yes, allow it to only go from state 1 to state 2, or by this thing. Do not let it go in a reverse way, so that if there are any errors due to random state changes, they get caught here, right? Then there is the actual transition that happens, and there is an on exit at the top. Then there is a broadcast to all the guys listening, and then there is the on init of the next state. So this is just wrapping all of it together. You have your validations, your actual transition that is there, and notifying the subscribers who are listening to it. So here I am taking the case of it's just this example called it's a ride sharing app or ride booking app, right, that you have. So there are typical, this is like a bare bone implementation, which I think is good enough to explain this concept. So you have certain states, and these are something which you can make on a paper and pencil as well, right? So you have to, if you were to define the journey of your booking an app, or booking a cab in an app, it will be something like, say you have a trip requested, which will go into a loading state for an API call. It will, if the payment is, if the API is successful, go into a payment requested. If that is successful, it assigns a driver. If it's not successful, it goes back up to trip requested, right? Fairly straightforward, simple definition. So now if you had to explain this as the schema or as the state machine, right? So we have a config, or these are the events: trip requested, loading, payment requested. And there's a default state at the beginning, which is like the ideal state. Ideal state when you load the FSM, right? Then there comes the case of if I have to define certain events for them. So I have only taken the case of the trip requested and the trip loading case for the sake of simplicity. So here we have, say, some events here which we define inside the trip requested, which is on click. So there is an event handler for trip requested in the trip requested state. There's an event handler for loading in the loading state. Similarly, for on message, there is another handler. And then there is a set of allowed transitions. So allowed transitions is, like as I said, the fallback or something which does the validation. This entire bit after this object is what I call, or what we call as the event context. So the event name is loading, and the event context is the entire object that is associated with it. Right now, what exactly? All right, so this is something where if you have a large number of events, this is something which can tend to grow, but you have all your event definitions here and their respective handlers for that particular event. And if you look at it, what are these handlers? These are nothing but just objects, JavaScript objects with those methods defined. So I will just get back to this bit a little later. So the first thing after this is how do I use this in the React app? Like you've mentioned the entire thing of what a state machine is and how do I implement it, right? So how do I use it here? So you have this so you can initialize because we decoupled the state transition from a React state. You initialize it at the top. Uh, then you have a component subscribing it to transition events, and you pass down the current state down, as a prop, or you have multiple components subscribing to the same thing, same state machine, or you can have a context API which passes down the value via a consumer. So either of these approaches works fine, depends on your use case. So if you have to do it as a class-based approach, this is purely for the sake of the demo, where you have a instantiate it at the top, and then you add certain listeners. You have a remove listener for cleanup, and then you have certain callbacks that you add for updating the state. Uh, Adding it inside an on-click event is you have on-click, which is probably passed down to a button. I'm sorry, which is passed down to a button, followed by you tell the FSM that yes, here handle this particular event for me. Now my UI does not know when I say handle event which state it is in, what it is in. It just says that yes, handle the event. The state machine does the required bit. If there are some changes, then it will propagate it via the listeners, the subscribers, to the component. Uh, since this is something where if you want to tie it directly to React and you have to make a hook out of it, this is what something that you could be, right? That you define a ref with the state machine and you have a current state which is empty. The callback, you can add a callback which does the handle event of it. The subscriber here, and then a use effect which will add a listener and then also remove the listener as part of the use effect cleanup. So if I had to use this in my component, the code drastically reduces. It's just that there is one on click and you have a handle event, and that will automatically, if the handler deems that a state machine transition should be made, it will get propagated into current state, and you should be able to see the changes happening here. Right? Now we'll just go back to the handlers that I had defined. So the trip requested, if you see, handler has an on event. Method handling, and here you can make your API calls, you can make transitions, you can have your error handling that you can do, you can push it to another state. Similarly here, if you see on message, the handler is empty. So what this means is that when this handler is empty, if I get an on message in the trip requested state, right, it will not be honored at all. It will. So this is how I won't get bugs from other asynchronous events in this particular state. Similarly, for payment requested, if I had to make an API call and then based on some value go to say state A or state B, you can make that transition. The driver assigned state does not have a on event or a button click here. It has in fact another event called complete click, which will do the transition here. So if I make the button click that I was doing in the earlier states in driver assigned, it will not honor it, and that event will get handled accordingly. Trip cancel is something which has a again an event defining. When you define an on event click, it will transition to the next one. So from what this entire thing, from what I'm trying to explain is, each state has certain event handlers, and the state machine decides what is the event handler to be executed based on the current state. And inside these handlers, if there is a transition to another state, then the respective components that are listening to it get notified. So this is a small demo which I had prepared for the sake of this thing. So say we have, so this is like the same Uber sort of ride sharing sort of a thing, right? So I have hooked it up to a socket message which sends a socket message. So when I do book trip, it goes from trip requested to a loading state where there's an API call made, which on successful goes to payment requested. Now it's the same button that I'm clicking and the same event, but because it is in another state, it is handled differently. So in this case, it is handled with get payment details, which say if they were successful, they get assigned, a driver gets assigned. Now at this point, say I get a socket message, right, which I've handled. In this case, the trip gets cancelled, and that same button that I was using, if I call this, it goes back to the trip requested state. So this is a very deterministic behavior of the UI, and other than the ones that I've defined for the same set of events, I'm able to handle the UI or the state in a different way. So let's say there's another, this where I say do book trip and say get payment details. If this is successful, driver assigned, I do an end trip, the thing ends, then the same button says give feedback, and then again it goes back to the book trip state, right? So again, it goes back to this particular page. So yeah, this was it. Then there is the entire concept of this state machine has been defined really well in this thing called Xstate Js, and David has made a fantastic library out of this. And we ended up doing our own bit of it because there were some parts that we needed, so we ended up implementing part of it on our own. But if you want to get started with state machines and implementing it in your UI, this is a good starting point. There's a very good YouTube talk of his on how they use CSS attributes, style attributes for dynamic, for giving style dynamically. That's a nice talk that you can refer to. Having said this, what went well for us, right? This was like an experiment, a POC that we tried. What went well? So structuring code was easy. The model that we made to define the UI became extendable. Transitions were easy, and it became extremely deterministic. It was easy to add recovery and error mechanisms in the UI, and this coupled very well with our whatever requirements that we did have, right? Of course, there were some learnings which we could have done, which probably we could have done better. But some of the learnings were that this is a hard concept for someone to grab in the first go itself, and it can be something pretty taxing for someone. And there can be a case of a state explosion, as it's called, where currently you have 3 states and they're all interlinked. Now, if you get a 4th state into the picture, what happens? Do you have a transition and communication between all those 4 states, or what is it? For this, there was a solve where you have something called a hierarchical state machine, where you have hierarchies, or a sub-state machine, and you give hierarchy to your entity and then solve it accordingly. So just in general, for the state machine part of it, right? I'm not saying that you should implement it right away and change your application to it. But if you start looking around, you'll start seeing a lot of UI components which follow this pattern. Onboarding screens, checkout processes, form elements, payment transaction pages, search input fields, all of these, if you define it and you need deterministic behavior here, the state machine approach can be something that can be helpful. All right, that was my talk. Thank you very much. I hope you guys enjoyed this.